Hey, good morning, awesome students. We are currently going live on YouTube. And let's just there we go. Okay, I'm going to mute this. And then I think we're going to be good. I don't know why I'm not seeing chat, though. That is something I will have to investigate. Because normally the chat comes up on the left. So let's see what might be preventing chat right now. Present to everyone. Chat. All right, well, I guess even though I am live, you will not be able to chat with me, which is totally fine. We don't need to chat but why is the chat not coming up? Because that is perplexing. Okay. Let me refresh the page. Maybe it'll magically appear then. There we go. There's chat. So I will type good morning. Woohoo! Okay, I did not post that I was going on because I figured most of you would be sleeping and you would not want a good morning text from me this early in the morning. That being said, I am going to do the review for the interim. Woohoo! We like our interim review because we want to be amazing. So if you are a student who happens to be subscribed to my YouTube channel, you might get the notification. However, I'm not going to wake you up in the morning with a reminder. However, when this is done, I will be doing that. So officially, good morning. Welcome to Dr. Erig's a crazy, quick geometry intro or interim review. What I have here is I have all of the questions that are on your interim review that is due tomorrow, which, if you're watching this in 2018, is Monday, October 15th, 2018, because that's when our midterm is for geometry. Now, as a reminder, this is the most challenging midterm that you will have most likely this year. It is the county's district assessment. I have no idea what's on it. Hopefully this review will help you when you prepare for it tomorrow, but it'll definitely help you for this assignment, which you had class time to do on Friday, but might need additional time. Okay, so let's get to it. These questions are out of order, and that is totally fine. You just have to find what they look like and then go from there. The questions are scrambled, and then also the answer choices are scrambled. So do not flip out if you're like, Dr. Erig, you're doing question 1, but this is question number 7 on my thing. No big deal. Just go through. Okay, so here we go. First things first. Okay, the figure represents a wooden truss that's very large that used to support the roof on a garage. What postulate or theorem can be used? Well, we have a side here and we have a side here. Now, technically speaking, why am I using the mouse and not my finger? Now, technically speaking, we could, with two sides, there's only two things that it could be. It could either be side, angle, side, or it could be side, side, side for proving congruent triangles. In order for it to be side, 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 we need to somehow get these points. Now, technically speaking, we could get those sides if we ended up using perpendicular bisector. And we know it's a perpendicular bisector for two reasons. First of all, this measurement here and this measurement here are identical. And because they're identical, and this is a right angle, we know that those sides are also congruent. But we don't technically know it's a perpendicular bisector. We'd have to prove steps to do it. If we had done all the steps, and this is like the second to last step, and we just have to say, how are these congruent? And we don't add any more steps. The only thing that we could do, actually, we can't do side, side, side because we can't write any more steps or statements or reasons to get that side for a perpendicular bisector. And we don't have the angle measures right here and here for side, angle, side. So we really can't use that. So instead of calling these things side, we actually have to call them hypotenuse and leg. The fact that this is a right angle, we probably have proven that it's a right triangle. And if you have a right triangle, you need the hypotenuse and you need the leg of the triangle to prove the triangle is congruent. The hypotenuse is always the longest side of a triangle, the longest side of a right triangle. So here's my right angle. The longest side, the opposite side is 13. And we have that. We have 13 and 13. We also have this 5 feet, which we know because of the reflexive property. Those are the same. So this one right here is hypotenuse leg. And I'm not going to say D simply because my choice answers are in different orders than yours. So mine is hypotenuse leg. Next. Question 2. How can we make this a little bit smaller? Let's see. I'm going to make it even smaller than that. I don't know if I can. So if the triangle 1 is transformed as shown in the diagram, resulting in triangle number 3, describe the transformations. Well, if we look at the picture, first we're going 1 to 2, and then we're going 2 to 3. Now, because I'm going from 1 to 2, see how this triangle is pointed up and this triangle is pointed up? All it did is it slid. Anytime things slide, it's a translation. So that was my first move. If it was a reflection, then it's still pointed up, but they look different because it flipped. So because the shape stayed the same, it just went, that's how we know it's a translation. Now, if it was a rotation, it would be like this, but then it would be like turned a different way, and it's not turned a different way. After the translation, it did have a reflection, and we can do that because we go 1, 2, 3, 4, up, and then down, 5 up, 5 down, and we have our reflection. And technically, it was a reflection of the x-axis. So our two things are translation and then reflection. Translation, reflection. So when we go over here, mouse tool, for me, it's choice A, translation, reflection. Okay, next page, please hold. Okay. Find the value of the variable. The diagram is not to scale. Okay, so a couple things that we know. I've told you before, you should always look for x's because x's give us vertical angles, which would be like this angle and this angle. And I've asked you to look for triangles because the sum of all measures in a triangle are 180. Technically speaking, you could also look for z's because that gives you congruent angles that are alternate interior. So if we look here, we have triangles. Okay, obviously we have a triangle. But in order for us to get this measure, we first have to know this measure here. So instead of looking for the triangle, let's look for the x. And here's our x. So if that is 114, that means that this right here also has to be 114. And the reason is because their vertical angles are kissing fish and vertical angles are congruent. They have the same measure. Now I have a better triangle. I know that this measure is 114. I know that this measure is 47. And now I can solve for x. Let's open up a calculator tool. Calculator. And then actually I can put that back. Oh, right, because I'm not on Google right now. So all I'm going to do is I'm definitely not going to use this Google calculator because that one is way easier. Here it is. Okay, so we're just going to take our 180. We'll subtract our 47, and the 47 is this degree measure. Then we're going to subtract our 114, and that leaves us a whopping 19 degrees. So that would be our choice here, choice B. All right, Google, you can go away. Can I move you into here? Yeah, let's do that, quizzes. All right, cool beans, trash can, next page. Boom, 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 boom. So again, my questions are not in the same order. You just have to match them up and look. Okay, this is a really great slide. This slide talks about perpendicular bisector, which we already kind of talked about in the first one a little bit. Anytime we have a perpendicular bisector, basically what's going to happen is these things here will always match up. Okay, these little triangles. They also create right angles And this side here and this side here will match up. Those are essentially the rules of it. So first it has JA, which means this point to this point, and this point to this point are congruent. That is true. Ooh. You know what? I'm going to write it next to here, and then you can figure out, because it's going to be mixed and matchy on yours. So this right here is true. So this is going to be a T or a 1. I'm just going to write the 1 to make my life easier. Okay. JI and JK. So here is JI and here is JK. Yep. Those are equal or congruent. Next we have AI and AK. Yep. That again, congruent. Let's see. How am I going to do this? You know, we'll still do that. 1, 1, 1. Okay, BI and BK. Here's BI, here's BK. Again, yep, that is congruent. I angle IAJ. So we're going to start at the I. We're going to go up to the angle, and then we're going to go down. And saying that that is a right angle. Looking at it very obviously, it's not a right angle. That's false. IJA is a right angle. So I start at I, drive your car to J, and then go down to or up to A. That is a right angle right here. So that's true. Next it says angle A or point A is the midpoint of IK. Dude, it's not even on the line. So that's false. J is the midpoint of IK. That is true. So really the only things that are false are E and G. Okay. Next slide. Where's my next page? Next page, trash can. Nothing like doing math on a Sunday morning. What? Which statement proves lines M and N are parallel? Remember, when we have parallel lines, we have all these different types of angles, but the converse is also true. If we have these types of congruent angles, we can then prove that those lines are parallel. So in this case, it says, how can we prove they're parallel? So which of these is true? So first we have, I'm going to use highlight tool instead, 8 and 2. Well, here's 2 and here's 8. They are called alternate exterior angles. Oh, that was simple enough. That is true. That's the correct answer. Let's look at some other ones real quick. 7 and 2 are called same side exterior. And oh, see, that isn't true. Catch got me there. This is when Dr. Erie makes a mistake and we're like, we learn from my mistakes. So this says 8 and 2 are alternate exterior angles, which is true. That is true. But they are not supplementary. Alternate exterior angles are congruent. So that is incorrect. Next, angle 7 and angle 2 are our same side. Yep, they're on the same side of that line. Here's our line right here. So they are on the same side of this line. And they're exterior. They're both outside the house. Here's the house. They're both outside the house. And they're supplementary. That's our true statement right there. Let's look at real quick other ones. 7 is right here. 3 is right here. Those are corresponding angles, but they called them alternate exterior, which is why that's wrong. 3 and 5 are alternate interior, and they call them same side exterior. So that is wrong. So the official answer is that angle 7 and angle 2 are same side exterior and supplementary. Next. Please hold as it goes to the next slide. Okay. We're waiting patiently and waiting. Okay, in the diagram below, triangle BCD, we have side DB is extended to point A. Remember, this is not one of the things that I said that you had to like, it wasn't look for the X, look for the straight line. Oh, I did say look for the straight lines. We know that a straight line is 180 degrees. Okay, so which has to be true? Well, we also learned that this angle right here is the sum of this and this. And we learned that because if we know a straight line has 180 degrees and we know triangles have 180 degrees, that's how it works. So for example, if this was 50, that means that this angle is 130 because a straight line is 180. We subtract that 50, we know we have 130. But a triangle is also 180. So if we subtract that 130 degree angle, that only leaves us 50 for both of these. And that's in essence what the proof is. So because of that, we have to look at this one more time. And we're going to be like, okay, can the measure of angle C be greater than D? Yes, it can be, but does it have to be greater? No, it does not have to be greater. It could be. We could have this be 100 and this could be 50 and this could be 30. That could happen, but it won't always happen because this could be 100, this could be 30, and this could be 50. So this is incorrect. The measure of angle ABC is ABC, this angle right here, is less than this angle. Well, the theorem is that the exterior angle is equal to the sum of these things. So that's not true. Angle ABC has to be greater than D because we have to be able to add these up because you can't have a 0 degree angle. So that can't be true because ABC has to be bigger than these two inside the triangle. ABC is bigger than C, which is correct. And then ABC is greater than the sum. It's actually equal to the sum of those two. So that's why it's not that one. Next. I clicked too many times. Hopefully I didn't make it freak out. I did make it freak out. Okay, we'll go back to that question after we let it load. Okay, here, well, we got it. Okay, if the measure of angle 8 measures 119, what is the sum of the measures 1 and 4? When I did this, honestly, I did not read the word sum, so make sure you read sum. Okay, so we have angle 8, and it tells us this is 119. I've told you to label your X's and O's. All of the obtuse angles get O's. So this is obtuse, this is obtuse, this is obtuse, this is obtuse. And then the X's are all the other ones. So we know that angle 5 has to be 119, angle 1 has to be 119, and angle 4. So now we're just adding these up. 119 plus 119 is 238. So it would be this one. Yay! Next. I know that threw that one fast, but you should have that one pretty much down. Next one. Here, I'm saying a lot today. Okay. Given that ABCD is a parallelogram, and if you want to go over here, I pulled it up here so you could look at it, but here's the stuff about parallelograms down here. A student wrote the proof below to show that a pair of its opposite angles are congruent. What is the reason for justifying that angle B and angle D match? I have taught you this a gazillion times. When it wants you to prove, if we are proving an angle is congruent to an angle, or a side is congruent to a side, we are going to use Cpctc. Corresponding parts of congruent triangles are congruent. The catch is, before you can use it, the step above has to be some kind of triangle congruence, okay? But to prove angles congruent, it's going to be Cpctc. Now, the difference, which is in the proof portfolio that you guys were creating, for the proof portfolio, I didn't always have the last step being proving they were equal. It might have been like AB equals 10. Because 10 is not another side, it's just a measurement, it won't be Cpctc. But in this case, because we're proving an angle is congruent to an angle, we know it's going to be Cpctc, which is corresponding parts of congruent triangles are congruent. Next slide. Y'all are doing great. Here we go. Okay, state what additional information you need to know these are congruent. Well, we have two angles, so we could either have angle, angle, side, or side, angle, side. Oh, not side, angle, side, angle, side, angle. They want us to use, though, what do they want us to use? They want us to use angle side angle. So that means we are making our sandwich. We are making our beautiful sandwich that is not from school breakfast. So the angle side angle means we need to have our bread angle, our goodies, our Chick-fil-A, our chicken, and then our side. So our side angle, side angle. So the bread is the angles, the sides in between. So that means we need to have sides only. So we could eliminate the ones that say angles. And then we need ZY because that's in between the two angles. And LM is in between the two angles. If it was this one, YX, this would be angle, angle, side, because that meat is outside the two pieces of bread. It's like the sandwich that you get from school. We don't want that. So this one would be this. Come on. Next page, please. And we're waiting for it to open. Writing a geometric proof. Which angle relationship can be used to justify that two angles are congruent? Congruent. That was a little flat. Sorry about that. Okay, congruent angles. Let's take a look. Supplementary angles we know equal 180. So it can be that one. Linear pairs also equal 180. Adjacent angles, if it's only two angles, then they can equal 180. If it's three angles, it's not always 180 because this could be less. So it's not this one. So we know it has to be choice D. Vertical angles are congruent, which is over here. So our alternate interior, exterior, and corresponding. Next page. Okay, I don't know why you're going so slowly. Which diagram shows a point P an equal distance from A, B, and C? So that would be, oh, wait, what did I do? No, I'm right. Here is the answer. And this is the idea of the centroid that we talked about before. Okay, centroid is the equal distant piece. And now I'm just doubting myself, so let's just double check that real quick. Centroid on a triangle. Yep, a centroid of a triangle is the intersection of the three medians or the average of these three vertices. So that is correct. Wait, I don't know if it's correct. Now I'm downing myself. Hold on. MA and BMC. I do not feel shame looking stuff up. I was wrong. See? 2 points lies perpendicular bisector of any. Nope. Let's look up Circumcenter. I don't think I taught you this one, which is surprising that I put it up here without teaching it to you. So that's why I want to double check. Circumcenter is the center of a triangle. Circle the pass through all trees, 3 triangles. All right, I don't think I taught you this yet, and I'm pretty sure I taught you the wrong one. So you are going to be putting centroid because that's the one I showed you in class, but I picked the wrong question, so I apologize for that. That is actually not the correct one. It's actually the circumcenter. So I own that mistake, and in growth mindset, it's totally okay. So I'm not worried about that question. All right, let's go to the next one. What I showed you was the combination of the midpoints. Where do the midpoints, the lines that connect the vertices to the midpoint, intersect at what's called the centroid? I messed up and showed you the wrong thing, or I put the wrong question here. So I'm not going to worry about that one. Okay, next, back on track. Supply the missing reasons to complete the proof. Okay, remember we look for straight lines, we look for triangles, we look for X's, and we look for Z's. It tells us that angle Q and angle T are congruent. It tells us that QR and Q and TR are congruent. And then here we've proven vertical angles are congruent. Okay. So how do we have here? We have angle, side angle. So that means that it can't be this one and it can't be this one because we have two angles on a side. And we know that because here's an angle here, here's a side here, and here's an angle here. So this has to be angle, side angle. And then remember, when we're proving and sides or angles equal to each other, then we know that it's got to be Cpctc, even though it looks like CRCCDDD, so that'd be choice D. Back on track, next page. And we're waiting for the computer to load. Here we go. Reflag. What transformation maps it onto itself? Basically, onto itself has to be the exact same position, but it could be rotated, flipped, etc. Reflect on the line y equals 2. Here's y equals 2. So if we reflect it on y equals 2, this would be the rectangle. So we know it's not that one. Next, it says reflect on y equals x. Well, this is y equals x. And we know that when we go over here, that we flip them. So that means at this point we go, and it would really be all the way over here. So it can't be that one. Next, it has x equals -2. Here's x equals -2. And this one would work because we can go 1, 2, 3, 1, 2, 3. That works. So this would map perfectly. So this is the correct answer. If it was the 180 around the point, it would actually look like this. Okay. And obviously that's not onto itself. So it's choice whatever. C. I don't know which one it is on your test, but it's C on my test. Next, what are the coordinates of the image of P3 -4 reflection of the x-axis? Remember that when you reflect on an axis, the axis that you're reflecting on stays the same. So it's like this point went to X's house, X stays the same, he's in charge. And then the other guy has to flip. So the answer is 3, 4. Okay, so if it was the y-axis, then -4 would stay the same, and then -3 would flip. Next page. Okay, which sequence of transformations does this? Okay, we have, let's make it more smaller. Hopefully we can get the whole picture. Reflect on the line x equals -1. Here's -1. So that means that our new triangle would look like this. So yep, that's true. And then slide it 1 unit down. That means it would just look like that. So it's not this one. We know that it is a reflection on x equals -1. That's accurate. This one says now 5 units down. So we start at a point and then we count 1, 2, 3, 4, 5. That is true. So it's B. If it was C, what would happen is, so we know it's going to be B. If it was C and it was a reflection or a translation, it would look like this. And then if it rotated 90 degrees clockwise, it would end up looking like that. So it can't be C. And then D is still the 6 units to the right, but counterclockwise would make it look like that. So, or actually, technically, it would make it look like that. So that's why it's going to be B. Next page. What additional information do we need to prove this? Well, we have the side here. We know that vertical angles are congruent, so we can either have angle, angle, side, side, angle, side, or angle, side, angle. BC and EC actually is correct. That would give us side, angle, side. If we did, and then remember we have this angle. Oops, pen tool. We have this angle here. If it was A, B, and DE, that would be this one, which would be a bad word. Okay. So we know it's not that. If they gave us AC and DC, they already gave us, so that's not additional information. And if they gave us angle ACB and DCE, well, we have that already because of vertical angles. So that's why it has to be choice A. What is the x coordinate of the image after reflection of y equals x? Okay, let's go over here real quick. I did give you these hints. Remember, anytime that we reflect over y equals x, we switch the x and y, just like we would with a rotation. So here, if we have 1, 2, and we're doing the reflection, we now have 2, 1. Because it wants the x coordinate, we know it's going to be 2. I did that kind of quickly because you should know that one for sure already. We did that a lot of those. What is your coordinate, y coordinate? If it's the x-axis, okay, we look over here. The x-axis, remember, same x, flip the y. So here's our -3, 6. The x gets to stay the same because it's her house. This one we have to flip. So this becomes -6. So if it wants the y coordinate, it wants the -6. I like these ones. The transformation ones are quick. As we wait. To be able to prove this using SAS, using the 2 given congruent corresponding sides. What else? So we need SAS. We have our sides, so we have to have the angle. The only angle that's in between those 2 sides are this one, angle A and angle C. So basically, BD is a side. BD bisects ABC. That gives us this angle, but that gives us angle side, which is, I'm not telling you what that is, but you know what that is. And then it being a right angle, that could help us for hypotenuse leg, but it doesn't help us for side angle side. So that's why it's got to be the base angles have to be congruent. Next, y coordinate, reflection, x-axis. I thought we did this one, but if not, here it is again. -3, +7, x-axis, so this stays the same. This flips. So the y coordinate would be -7. And again, read it over here. Same x, flip the y. None of you got my notice, which is great. I never sent it out, but I was just wondering. Anyone on YouTube in the morning? Triangle's congruent. Which angle is congruent to triangle U? Remember that P, highlight tool, blue. P matches S. Q matches T. And R matches U. Okay? Order matters. I've told you this 1,000 times. I don't know if I've sung it to you 1,000 times. I've definitely told you. So it's simple. U goes to R. Ta-da! Oh, man, if only we got a question that easy. Wouldn't that be amazing? Simple question. I know why these are easier because I put my hard questions first. That's why these are easier. Which of the following is a precise definition for angle? The precise definition is that they are formed by 2 rays. Okay. We don't use line segments because basically it's 2 rays. A line segment could cut it off, but really it's 2 rays. That's the precise definition. These were going. Which of the following is not an isometry? Well, you know over here that isometries are not dilations, and because dilations are similar. So the only one that has dilation in it is choice B. Where are we doing? So this is not an isometry because it's got dilation. These, you know, gets easier. Boop, boop, boop. I think it takes longer to wait than it does to actually do it. Which word is not synonymous with rigid? Well, we know preserves distance, congruent shapes, only rotation. Oh, there's the word not, dilation, similar. So obviously it's going to be A is not synonymous with rigid. Synonymous is like a synonym, which means the same. So similar is not the same. Okay, next. If a rigid transformation maps, let's look. Come on. Which is congruent. I guess I have to use my mouse. RW. We're looking for RW. So here we have KMQ, WJR, and we're looking for what matches to RW. So K matches to W, M matches to J, and Q matches to R. And they want R, and then they want W. So simple enough. R matches to Q. W matches to K. QK. Ta-da! Order matters. That's why I told you when we were first doing this, don't be lazy. Just make the letters match. Don't be lazy. Just make the letters match. Finley has created triangle HJK through a series of transformations applied to triangle DEF. The transformations she used are listed below. Reflect on a vertical line, rotate. Are they congruent? Oh, I wrote that twice. Isn't that lovely? Well, because it says the word reflect and the word rotate, they are congruent. So we're not going to do no's here. Now let's see. Yes, because the transformation taken alters the angles. It does not alter. It preserves. Oh, look at this beautiful word preserve on your review sheet. So yes, because the transformation taken preserves. Okay, I don't know why I had that twice, but life goes on. Next page. We're almost done. Yay! Hopefully they'll be just as quick as our last ones. Which of the following are properties of parallelograms? So we're going to go over here. And we know parallelograms have opposite sides are congruent. I'm looking at this part right here. So opposite sides are congruent isn't one of them. Opposite angles are congruent. So we know it's going to be number 1. Diagonals are perpendicular. That is not one of them. So it's not going to be number 2. Adjacent angles are supplementary. I don't have that written there, but that is true. Adjacent angles are supplementary. And diagonals bisect each other, which is also true. So 1, 3, and 4 for mine is choice D. Probably shouldn't be blowing into the microphone. Which statement proves that they are parallel? Let's look. 8 and 2. Here's 8. Here's 2. They're alternate exterior angles. Yes, they are. And they're congruent. Yeah, they are. Alternate exterior angles congruent. 7 and 1, they're not on the same side. 7 and 3 are actually corresponding, not alternate exterior. 3 and 5 are alternate interior angles, but they're not supplementary. Alternate interior angles are congruent, as you can see somewhere here. Okay. Oh my gosh. Here's another typo. Darn. That's what I get for not double checking my backside of my paper. You know what? Let's fix that right now. So if you have your paper, let's just real quick fix this. Because I want to make sure that you have the right thing. So I do not have a problem taking 20 seconds to do that real quick. Because you all know if I don't do something right away, I will forget. I don't know if you're like me, but that is the truth. So I'm going to come down here and alternate interior, exterior. Come on, Google. This is how we wait. Andi, my niece, would say we're waiting. Alternate interior, exterior are congruent, and they form a Z. Okay, and you can fix that on your paper. And remember, if you do stuff on my drive, it's automatic. All right, next. Pentagon is centered at 0, 0. There's the vertex. Which transformation will map it onto itself? A reflection of line M would make it look like this. So that's not it. A reflection of the x-axis. Here's the x-axis. It would be something like this, which obviously is not it. Now, rotation of 100. If we come over here, I told you that you take 360, divide by the number of sides. A pentagon has 5 sides, 2, 3, 4, 5. Divide by 5. 5 goes into 36 7 times 2. So every 72 degrees. So we have 72 times 1 is 72. 72 times 2 is 144. And that is how we got choice D. If you don't remember that, watch my other videos, but it's also right there. Almost there. Come on. Promised land. Let's get this done. Get this done. Next. What is the correct 2-column proof? Well, we have given. Check. Angle P. Here's angle P. Angle D are vertical angles. That's true. So that's good. That's good. Angle D. And angle C are supplementary. That's true. Same side interior. Angle C and angle K are vertical angles. That is true. And then so, oh, choice A. Yay. Waiting, waiting, waiting. The diagram below, they're cut by the transversal. What value of x? Remember, we look for straight lines, which are 180. We look for x's, which are same or congruent. We look for z's for these interior ones. And we look for triangles, which are 180. Okay, so we could do a couple things. We could do a z here. And that would make this 30. Alternate interior angles. We have our x here, which makes this 80. And then we know that a whole triangle is 180. So when we subtract that 80 is 100. And then we subtract our 30, we get 70. That's not the only way that you could do it. Some kids did it where they, how did they do it? Oh yeah, some kids found this and found that and then did alternate interior, that going in reverse. Doesn't really matter. That was fast. Hopefully you knew it already, or you can watch it a couple times, because I would like to get this video done. It is long enough. The image after reflection of x equals 2. Okay, here's positive 2. Negative 1, positive 3. That's here. So we need to do 1, 2, 3 hops to get to x equals 2. 1, 2, 3 hops back. That gives us 5. 5, 3. Oops, that was wrong notation. Is the correct point. 5, 3. Next. 5 left. Yes, yes, yes. Which can be shown with these following 2 transformations. Okay, a reflection over the x-axis would make it down here. A reflection over the y-axis is correct. A translation of 4 units means that it just slid over 4. So it didn't change orientations. This one, it clearly flipped. A rotation of 180 would put it down here. So that's why it's reflection over y. Some of you told me in class that some of the questions were very easy, and those were the ones that came from all the geometry teachers. The ones that your brains had to really think hard, those were the ones that came from me, because we know that when we work our brains hard, we do better. All right, which is correct labeling. Now, when I did this question the first time, I was like, okay, this matches, this matches. Notice here, all of these match the same. We just have to discover why. Here we have an angle. Here we have a side. Here we have an angle. So it's angle, side, angle. If it was like this, angle, angle, and then this side, that would be angle, angle, side. But because the side is in between the two angles, it touches this angle here and it touches this angle here. It touches both angles. That is why it is angle, side, angle. Question number 30. I don't remember what number 5. Which does not preserve distance and angle measure. Again, you know that already. This one, it should be like the easiest one that everyone gets right. That is dilations. Dilations are similarity. They preserve angle measures, but not distance. Next page. Question 36. Y is QS. QS, that is obviously a reflexive property. There's no such thing as a symmetric property, or that I can know. Altitudes form right angles from a point, which I haven't really talked to you about yet. And transitive property is like x equals y, y equals z, therefore x equals z. So that's clearly not anything of this. It's just the reflexive property. Oh, that's cool. Look at that. Ooh. Clearly, I'm ready for this to be done because we're on the last question. Victory, last question. Next. Waiting. The coordinates of any point, x, y, after the reflection of x-axis can always be represented as how. I put this one in on purpose because some of you are going to be like, Dr. Ehrig, I don't know what to do. But yes, you do. You write x, y down. We know that anytime it's the x-axis, this stays the same. And this becomes the opposite. X negative y? I can't believe it. X negative y. All right, lovies, that is it for me. This is the most important thing that you need to pay attention to, is definitely getting that interim review done. This is what you should know cold. If you know this cold with that little change right here, then you should be fine for your test in terms of the content. Remember, the midterm has very long, wordy, confusing questions. So you're going to have to take your time and read through it. I'll remind that to you tomorrow. But you guys are amazing. You've been working really hard. I'm really impressed and proud of you. And I know that you will be successful. So that is it for me. Bye-bye.